Hi, welcome to the Derek Show. And for this episode, what I'm going to do is talk about those. You know how when you go to a Disney World, there's those little droids you can take your kids to go and build in the Droid Depot. It's in Hollywood Studios Park, and the area itself is called Galaxy's Edge. So it's basically related to Star Wars. What I did was I did some research and found out how that droid behaves and learn from some other people and basically create a beacon for this a beacon using ESP32. The very basic ESP32 is the ESP IDF, just to basically make the droid think it's still in Galaxy. Okay, so the first thing I want to do is talk at a high level how the droid works and how it interacts with Galaxy's Edge and Disney World. So essentially, the droid has it communicates using Bluetooth Low Energy, BLE standard. And throughout the Galaxy's Edge, there are location beacons that also transmit advertisements in Bluetooth Low Energy. And the droid receives that, and then it plays out a certain noise depending on what the beacon advertises. Additionally, the droid itself has a BLE beacon that it sends out to identify itself, and if another droid picks it up, they can interact that way. So that's their secret. That's their trick. They're just using Bluetooth Low Energy to facilitate some type of interaction for the kids. Last, I'll note, they also use Bluetooth Low Energy to control the droid.
So I want to take some time now to talk a little bit about the ESP32 from Espressif Chip. Espressif is a company based out of, I believe, Shanghai or Shenzhen, but I think it's actually Shenzhen, sorry. And they make pretty good microcontrollers. Like they have the Wi-Fi and Bluetooth already included in the microcontroller chip, and they have a pretty decent SDK out there, and most importantly, they're very cheap. Now I know I should try to, I will eventually try to put on like Arduino or put this stuff on Arduino or like Texas Instruments, but I gotta say the ESP32 is in my price point. I'm not a rich man, so I have kind of stuck with it. So that's why I chose the ESP32 for this case. So right now, I just want to confirm that what I built this demo on was with ESP IDF version 5. And I built it using the typical the ESP IDF way, copy their sample code into my own directory, made the modifications, and then run the build in that window using idf.py, right, commands. I did it because I'm most familiar with that. Now the new ESP IDF5 also comes with an integrated development environment, or IDE, that looks like it's based on Eclipse, right? So you can download. That's easier to use. But since it's easier to use, but because I'm not familiar with it, I decided not to use it. So that's why my video only shows like the old way, and you'll see that as it goes on. It's enough. It's simple enough, right? But I'll try out the new Eclipse IDE in the future. Also, I'll continue on my little tangent here and go a little bit back to architecture, which I showed you before. Very simple for this demo. I think it's important to always do an architecture or design before you actually start coding, just to make sure your head is screwed on right and head in the right direction. So one of the things I did, I used this new experimental language that was put out by Carnegie Mellon University's Software Engineering Institute. They do research into different software systems, specifically mission-critical real-time ones, like you see in things like the U.S. military, which I think is one of their big customers. So anyways, I tried to model this using the AADL, Architecture and Analysis Description Language. that they provided. I kept it very simple. I just draw the shapes and had the types, and that's it. The language itself, which has features that I eventually plan to take advantage of, are attributes to these elements you see in the design here. And what you can do is you can set different values for like data flow speed or CPU speed, and it can do in the language basically if you get the right plugins, it can perform some type of analysis based on what you put in for those values. And they'll tell you whether the system will be able to respond within the time frame or time limit that you set, or they'll do the flow analysis for grabbing data from sensors to make sure that you can continue to analyze and process the data as it flows in, type of thing. So let's take some time to talk specifically about the actual Bluetooth Low Energy or BLE advertisement we're going to set. Okay. So some people have been very nice. They've already been snooping around Disney World and Disneyland in the Galaxy's Edge area, the Star Wars area, and with the right tools, been listening in on the BLE signals coming in. They posted it. So I started from there. What I found out is that the location beacons, like the ones nearby Olga's Cantina or Droid Depot, whatever, what they're saying is they all send a very basic advertisement. It's all on the manufacturing data. You don't need to put anything else anywhere else. Just load the manufacturing data with the right information. And what happens is if you load this ESP32 to do that advertisement, there is a specific to do the manufacturing data. It basically is an array of 8 unsigned chars, right? Or unsigned ints, actually. So, and you can put information in each of the slots of the array to make the advertisement for so that when your droid comes by and picks up the advertisement, it'll react. So the first thing is important is you got to get the stuff in the right order in that array. Okay. So the array's 8 slots. I'm going to have it here, number like 0 to 7 in computer notation. And you notice that when you look through the other sites that did this research, they did it. They captured the bytes that are sending the advertisements in hexadecimal, which helps. It makes it easier. But you got to know the order in which to put them in the array. Very important, otherwise it won't make sense to the droid. So the first byte, it's slot 0, you put in 0x83, and in the second byte, in slot 1, 0x01. Those 2 bytes basically make up the manufacturer ID. And you'll know when you put it there and you advertise it from ESP32, it'll show up on your iPhone app that listens into Bluetooth as manufacturer ID of Walt Disney. That means you know you're broadcasting the right ID. Then for the actual advertisement, that means whether it's in front of Olga's or it's in the Droid Depot or Doc Ondar's, you see it. You put it in the same order, left to right. You split it basically every 2 characters in the hexadecimal string goes to one of the array slots. So the third one goes the first 2, which is 0. In this example, I have it 0A, and then the second one, the next 2 go to the next slot, and so forth, all the way down. Okay, so this one, I have an example here. I believe here it is. I did it as the marketplace or the outdoor areas. That's what I put in. But you got to split an array that way. Otherwise, when you send your advertisement through the class HFVs, it will not make sense unless you put it like this. Okay, so you have to do it this way so the droid understands. So one of the things you'll notice by looking at my source code is that I chose we do everything in C++. You'll see that if you look at the app main function, there's an extern C to basically expose it to C. But the compiler still builds the C++ code. It's fine. Why did I convert to C++? Well, because I guess I'm a true developer. I like to do things my way. No real reason whatsoever. In fact, it's probably worse from a real-time perspective, as C++, I heard, is slower, even if you do it according to real-time constraints. Okay, anyways, now that you know that I did the code in C++ for fun, I want to walk you through the code first, very quickly, just to show the logical, the functional view of it, how the flow works. So, first thing I do is I determine what the advertising, what my BLE beacon should be advertising. So as you can see, I use some ESP32, the ESP IDF, their library, to have some objects or structures that already represent this stuff. So for the case of the advertisement, it's really two things, right? First, there's the params, which you'll find in the ESP_BLE_ADV_params_T. That sets the params for the advertisement. Advertisement itself we'll put in this structure, the ESP_BLE_ADV_data_T. And then what I do is basically I first set the parameters up, and then I build up the bytes that I want to advertise, right? So as per the spreadsheet, I put it first in my own array here. I put in the manufacturer ID for Disney. Then as you can see, there's a bunch of pre-compiled directives here. And what happened is that I will show you later, but I can select basically using the menu config feature of how I want to build this code. So I can set these values in a nice little DOS prompt type of menu, character menu type of application that I can basically decide to build it as a marketplace BLE beacon, or a droid depot one, a resistance, or dock on doors, first order area, anything, right? Even the Olga's Cantina. So that's the first thing there. Build up the advertisement based on what I want the beacon to represent. Then there's some parameters in there I just took from the documentation, put in the defaults. Then there's I have to basically initialize the Bluetooth, the BLE component, with the ESP Blue Droid init and the ESP Blue Droid enable. Then I pass in first my the advertising data itself I want into these components using the ESP_BLE_gap_config_ADV_data function. That I just pass in a pointer to the advertisement structure I have in my class. Then next I tell it to start advertising using ESP_BLE_gap_start_advertising. And I pass in the advertising params structure, or a pointer to it. And then that basically triggers the ESP32 to start advertising now. And then all it does is just broadcasts that signal indefinitely. So that's basically it for the code, at least functionally how it works. So anyways, I want to talk a little bit more about those pre-compiler directives or constants I have in the code here to tell it what beacon it is. So you notice that each one of those variables I put in is all begin with prefix config underscore. That's important, okay? Because and you'll see that when I show you the actual file, the menu file where you can tell how to set these values. I don't actually have the config underscore in those, but the behind the scenes kconfig menu builder process adds it in. So your code has to have it in order for when it builds the actual application, it can actually get the value for it, right? So let me talk about the kconfig.proj build file, and I want to show you it. So if you take a look here, you'll notice that, okay, it has some syntax. It's all tab based, so it's a token file, right? So it's separated by tabs, or spaces, actually, spaces, sorry. So at first I gave it a name for the general menu for the app, and then each has different menu for basically selecting what type of beacon you want. And the way I set up, this is the only way I could get it working, but basically you have to go into a separate screen for each beacon choice and either mark it as on or mark it as off, right? So you have to go through each one and make sure only one is on, the rest are off for the beacon app to work properly. That's because I think my knowledge of kconfig is very weak. So here, this is what the menu looks like. You just have to type in idf.py menu config into the ESP IDF command prompt in order for this to work. Right? But it's just a simple, like a DOS-based menu. And you scroll down a bit, move down the cursor keys, you can go to different options. So I created a high-level menu item, this one, the beacon choices one, and go into it. You'll see that I have each of the different locations also as submenus. And you go into them, you'll see that you can either set it on or off, right, based on by pressing Enter key. That's it, basically. So but at least you set the type of beacon here. You don't have to change the source code every time. It's a lot easier. So next I'll just show you how to build this code. It's very simple. ESP-IDF, I just type idf.py and build. As you can see, you'll start building it. It takes a while to build all these executables and stuff. It's just the way it is. But especially if you start, if you have to start brand new, then you have to basically do an idf.py build, idf.py clean first, then you can do a build, right? Because you can't just build using the previous code's binaries. You gotta rebuild everything from scratch. Now I'm just going to flash the code on the app using the idf.py and then app flash command. As you can see, it's pretty quick, and for me it's pretty easy. For this board, it just goes on, but some of the ESP32 boards you have to press and hold the reset button first for a little bit, and then let go, and then it allows you to flash the chip. So now I'm going to just listen to the COM port that I attached my board to using the monitor command, and I'm going to prove to you that the selection in what I did in that menu previously now is reflected for the login statements. Read carefully, you'll see it just goes and it only loads the advertisement for the beacon I wanted. So finally now I want to demo this. So as you can see, I powered up my beacon. I'm just going to hold the droid near to it, and then now first I already powered off and powered on the droid again to make sure it's reset. And there seems to be a little bit of timer or some delay, so I'll have to wait maybe a couple of minutes, but eventually it will react to the beacon noise by making some sounds. Okay, so anyways, I'll just leave this going until it has the reaction. So thanks for watching the Derek Show, and I hope to see you again soon.
Actually, before I leave, I just wanted to point out, I forgot to mention this, is that what I did was I took videos of all the different beacons and how the droids react to them, just so you can compare when you're doing your testing. You can see my testing and compare against yours. So thanks again for watching the Derek Show, and hope you have a great day, and hope to see you again soon. Bye.